On the top of the page is the formula to find the arc length of a circle. So an arc is part of the outside of the circle, and the outside of a full circle is called the circumference. So basically we're finding part of the circumference of the circle. So when you look at the formula, you'll see it has 2 pi r. But since we're only finding part of that distance or part of that length, in front of it we're going to multiply by n over 360, and n represents the number of degrees in the central angle. So number 1 says to find the length of major arc PQ in terms of pi. And I've already highlighted the major arc PQ. Major arc is more than 180 degrees. That's why I went in that direction. So first I'm just going to write the formula. And for arc length, we use the variable of s, which may seem kind of strange, but we can't use a for arc length because a is area. So instead, we just used s instead, I guess. Okay, so there's the formula. We don't know the arc length, so I'm going to leave it as s. The central angle that goes with that arc, that intercepted arc, is 210 degrees over 360 times 2 pi, and the radius of the circle is 12. Because we're going to leave our answer in terms of pi, you would type all of this in the calculator, just don't type the pi. So you type 210 divided by 360 times 2 times 12, everything but the pi, and you would get 14 pi. Number 2, find the length of minor arc MN. That's why I already highlighted the arc that's less than 180 degrees for a minor arc to the nearest tenth of an inch. Okay, so let me just first write the formula. Now the central angle in this case, it's not always what's given to you. It's not the 270 degrees, because that's not the central angle that goes with a green intercepted arc. This is right here in blue. That's the central angle that goes with minor arc MN. So if you just take a full circle 360 minus 270, you're going to have the central angle is 90 degrees. So I'm going to plug in 90 for n, the central angle, over 360 times 2 pi, and the radius is 4. And the question says to find this to the nearest tenth of an inch, so you would type everything into the calculator, and you would get 6.3. And number 3, we want to find the exact length of arc AC, which I've highlighted in green. It says the measure of angle ADC is 50, and the radius is 4. So when we use the formula, you have to remember that n is the number of degrees in the central angle. And right now, 50 degrees is not the central angle, so we have to find it. So if I just draw in the central angle that's going to go with that green intercepted arc, here we go. We have to find that. Well, 50 degrees is an inscribed angle. An inscribed angle is half of the intercepted arc. So that means the intercepted arc is 100. And the measure of a central angle is the same as the intercepted arc. So the central angle turns out to be 100 degrees. So n is 100. The radius, it told us, was 4. And again, it says find the exact length of the arc. So you do not type the pi in the calculator. And it comes out to be 2.2 repeating pi. So let's do some different types of problems. Number 7 says an arc measures 60 degrees and has an arc length of 5 pi centimeters. So first thing I would do is just write out the formula. And it says, what is the radius of the circle on which the arc sits? So just going to write the formula, plug stuff in. It told you the arc length is 5 pi. The arc measures 60 degrees, and if you remember, a central angle is the same degrees as the intercepted arc, so that's why we can put 60 for the n. And we don't know the radius, so I'm going to leave the radius as r. First thing I do is, if you have pi on both sides of the equation, you can just cancel them out. And I'm just going to rewrite this, so I just have 5 on the left-hand side. Now, over on the right, I like to make this into one single fraction and then cross-multiply in the next step. So this is really over 1. So if you look at it on the top, it's 60 times 2 times r. That would be 120r. And on the bottom of the fraction, we have 360 times 1, which is just 360. I'm going to put the 5 over 1 and then cross-multiply. So 5 times 360 is 1800. Equals 120r times 1 is 120r. And then if you just divide both sides by 120, you will have the radius, which is 15. Okay, another problem, number 8. I'm just going to write the formula first. It says to find the measure of the central angle whose intercepted arc length is 14 pi and radius is 18. So this time we're looking for the central angle. Okay, so S is the arc length. We know that. It said it's 14 pi. We don't know the central angle. Let's just leave that as n. And the radius is 18. So first step, just like before, I'm just going to cancel out the pi's, and then I just want to make the right-hand side into a single fraction so we can cross multiply in the next step. So if you put this over 1 on the top of the fraction, we have n times 2 times 18, which would give you 36n. The bottom of the fraction, 360 times 1 is 360, and then we are just going to put the 14 over 1, cross multiply. 14 times 360 is 5,040. 36n times 1, 36n, and you just divide both sides by 36. There's different ways to solve these. I like to make it just into a fraction and then cross multiply, but some people like to change it into decimals. Just as long as you're getting the same answer, then whatever way works. And that was the central angle, so I labeled it as 140 degrees. Just one more different type of problem here, number 9. So a circle has a circumference whose length is 25 pi. Okay, so I'm just writing out the formula here. Find the exact length of an arc whose central angle is 90 degrees. So it says to find the arc length. Find the exact length of the arc. Okay, we don't know the arc length. The central angle is 90, so 90 can be put in for n. And it doesn't give you the radius, but it says the circumference is 25 pi. Well, 2 pi r is the formula for the circumference of the circle. Therefore, I can completely replace 2 pi r with 25 pi because it said that was what the circumference was. Okay, so at this point it says to find the exact length of the arc, so you just want to enter this in the calculator. Don't type the pi, so you're just typing in 90 divided by 360 times 25, and you get 6.25, and then we still have the pi, so we have the exact length of that arc.